To find the given partial fraction decomposition, first you must realize that this is an improper fraction because the leading term in the numerator has a greater degree for the x than the denominator leading term, right? X to the fourth versus x to the fifth. So we must use long division to reduce this fraction, right? To have a quotient with the remainder being divided by the divisor. Right, so let's do that. So we're going to put x to the fourth plus 20x squared plus 64 in the divisor. Okay, in the dividend we're going to put 2x to the fifth. And notice there's no x to the fourth, so we just do 0x to the fourth to fill in the spot. Then 42x to the third plus x squared plus 124x plus 16. Okay, so now we bring the first term, we divide it by the x to the fourth, we get 2x. Now we multiply this back. We already have the first term, 2x times x to the fourth. Notice there's no x to the fourth in the divisor either, right? So we just put 0x to the fourth. Now 2x times 20x squared is going to be 40x to the third. Okay? Now there's no x squared, so we're just going to put 0x squared. So plus 0x squared. Now 64 times 2 is 128, so 128x. And then finally, there's no constant, right? So we just put plus 0. Now we have to subtract this. Remember that we have to subtract this. And we have to subtract knowing that the minus distributes to every single term here. So we get a 0 here, we get a 0 here. We get 42 minus 40 is 2. 2x to the third. X squared minus 0x squared is still x squared. 124x minus 128x is minus 4x. And then 16 minus 0 is still 16. So the answer to this is, as you can see, 2x, right? Plus, and now we're gonna have a fraction that we're gonna use to find the partial fraction decomposition, right? So what we get here is the quotient and also the additional fraction, which is comprised of the remainder, 2x to the third plus x squared minus 4x plus 16 being divided by the divisor, x to the fourth plus 20x squared plus 64. Now notice that in order to find the partial fraction decomposition here, we need to first factor the bottom, right? X to the fourth plus 20x squared plus 64 can be factored as x squared plus 16 and x squared plus 4. Notice that these are two quadratic prime factors. They cannot be factored any further. So basically, whenever you have a quadratic prime factor, you're going to have two constants associated with it on the top in the numerator. So in the bottom, you're going to have the first prime factor. And in the top, you're going to have a and b. Now, a will be multiplied by the x. Make sure that you don't just write a plus b. Ax plus b. Right? And the same thing for the second prime factor, x squared plus 4. We're going to have a set of two other constants, or additional constants, right? So the next one is c, and make sure you understand it's multiplied to the x, just like the a did, plus d by itself, just like the b was. Right? So this is going to be what you're going to work with. So now, multiplying both sides of this equation by the original denominator eliminates the denominator on the left side and just gives you the top, right? So 2x to the third plus x squared minus 4x plus 16 is equal to, now take a look at this. Ax plus b will have the x squared plus 16 canceled out if we multiply both sides by the original denominator, right? So ax plus b will simply multiply the x squared plus 4, right? The denominator that it does not have. Okay? So I'm just going to write ax being multiplied to x squared plus 4. Then I'm going to add the b being multiplied to x squared plus 4. I just want to split the letters a and b. And now cx plus d will be multiplied in the same fashion by the denominator that it does not have, which is x squared plus 16. Right? So cx multiplies by x squared plus 16. And then d also multiplies by the x squared plus 16. Okay, so now that we have that, let's compare the powers. So x to the third power, we have to have the coefficients on both sides being the same, right? So 2 on the left side must equal a combination of letters that multiply x to the third. Okay, so let's see. So definitely you see here the first product is x to the third, so a multiplies it, so we're going to put a. B doesn't have x to the third. C has one, as you can see, so a plus c. And d doesn't, right? So that's enough. Now x squared. Now what I want to do, I'm going to move the c guy a little bit further, just so that we can place everything vertically, the letters vertically. So x squared coefficients now. We have 1 here as the coefficient on the left side. Let's see if we have a. A cannot have a, well, let's see. No, a does not have x squared anywhere for its terms. B has 1, definitely, bx squared, right? So we can write plus b. Okay. C does not have x squared. D has 1, right? So plus d. Now for the x to the first power, let's see what we have. We have minus 4 as the coefficient on the left side. And on the right side, we have ax times 4, right? So definitely 4a. There's no x for the first power for the b. C does have 1, right? 16 times x, right? So 16c. So plus 16c. And d doesn't have 1. And now finally, for the constants, x to the 0th power. Now we have plus 16 by itself on the left side as a constant. Now what constants do we have? A and c are not counted because they're attached, glued to to x, right? The x doesn't let them be by themselves, right? There's no way they can be constants associated with a. So b and d have constants, right? Because 4b and 16d, right? So 4b plus 16d. So now I'm going to circle the equations that make sense to work with. Like that, so you get to see which ones we can work with. Okay. So now, so 2 is equal to a plus c, so let's solve that. 2 is equal to a plus c, and minus 4 is equal to 4a plus 16c. So as you can see, if we multiply the first equation by 4 and then subtract the second from the first, we will have eliminated that problem. Right? So I'm talking about multiplying this by 4, the entire equation. Then we subtract the second from the first one, and we will have eliminated the a letter, and we just solve for the c constant. So 8 minus negative 4 is 12, right? So 4a minus 4a is 0, right? This is what we wanted to do, eliminate the 8. And 4c, right, 4 times c, so 4c minus 16c is negative 12c. So as you can see, this solves for c successfully. C is equal to negative 1. As a result, let's circle that. So c is equal to negative 1. Now, if c is equal to negative 1, we can use this original equation here. A plus c was equal to 2. That means c is negative 1. If we add 1, we get 3 for the a. So a is equal to 3. A is equal to 3. Good. Now, let's bring the second pair of equations that we can use to find the constants. We know 1 is equal to b plus d, copying this equation. And now 16 is equal to 4b plus 16d, plus 16d. So what we can do here, we can eliminate the b's by multiplying the first equation by 4, in the same way that we've done in the previous set of linear equations, right? So we can multiply this by 4, this equation by 4, and then subtract the second one from the first one, and that will eliminate the b's and just solve for d's, right? So we got 4 times 1, 4 minus 16 is minus 12. 4b minus 4b, remember this negative applies to all of these terms, right? Minus applies to all. So 4b minus 4b is 0, what we wanted. 4d minus 16d is minus 12d. So as a result, d is solvable. D is equal to 1, right? Minus 12 over minus 12 is equal to 1. Right? So we solved for d, that's good. So d is 1. And if d is 1, we can easily find the b value using the original equation there. D is 1, subtracting 1 gives you the b value of 0. Right? So the b value is 0. Good. So now we can find the answer to this problem. Right? So 2x plus ax plus b. What is the a value? A value is 3, right? So 3x plus b. The b is 0, so we don't write anything else. X squared plus 16 plus, let's see, cx plus d on the top for the x squared plus 4. C was negative 1, so minus x, right? Plus d. Now the d value is 1, right? So plus 1 over x squared plus 4. Okay, so you have successfully found the partial fraction decomposition representation of the given intricate fraction in the beginning. So thank you so much for watching. Hope you enjoyed it, and I'll see you in the next video.